Welcome to Future Doctor NEET Academy for the problem solving session in NEET Physics. Topic chosen today is from Chapter 5, Magnetism and Matter. Let's discuss first question. A 250 turn rectangular coil of length 2.1 centimeter and width 1.25 centimeter carries a current of 85 microampere and subjected to a magnetic field of strength 0.85 Tesla. Work done for rotating the coil by 180 degree against the torque is dash. That is, formula used is W equal to mb cos theta 1 minus cos theta 2. And here m is the magnetic moment, and in terms of current flows, m equal to NIA. M equal to NIA. This is the formula. Okay. And theta 1, theta 2. That is, from 0 degree is rotated to 180 degree. So 180 0 means cos 0 is 1 minus cos 180 minus of minus 1. Therefore, W equal to mb into 2. That is 2m. B and m equal to n into I into A. 2 into m into n, that is m is 2 into m is n I A into B. Okay, and W equal to 2 into n. N is the number of turns, 250 turns. So 250 into A. A is length into breadth, 2.1 into 1.25. 2.1 into 1.25 centimeter to meter into 10 power minus 2 into 10 power minus 2, 10 power minus 4 into 10 power minus 4 into, that is the area, into B. Value of B is 0.85. 0.85 and I we missed. Yes, then we put I into I. I value is how much? I value is given 85 microampere. 85 into 10 power minus 6. Okay. And if I simplify this, you will get W equal to 9.4 something into 10 power minus 6 joules. Approximately, as per this, 9.1. 9.1 microjoules. Which option? Option A. Option A is the correct answer. Let's move to question number 2. Following figures shows the arrangement of Bohr magnets in different configurations. Each magnet has magnetic dipole moment, capital M. Which configuration has highest net magnetic dipole moment? These are the 4 different configuration. That is, 2 Bohr magnet kept perpendicular like this, another one parallel, another one kept at 30 degree angle, another one kept 60 degree angle. Formula for resultant magnetic moment, M equal to square root of M square, that is M1 square plus M2 square plus 2M1 into M2 into cos theta, and M1 equal to M2 equal to M. So M equal to square root of M square plus 2 M square plus M square plus 2M square cos theta. So everything is same, theta only changing. Cos theta, this is 90 degree, and this theta is 180 degree, and here 30, here 60. Cos 90 0, cos 180 also 0. So its value is least. Cos 30, what is the value of cos 30? Cos 30 is root 3 by 2, and cos 60 is 1 by 2. So comparing root 3 by 2 and 1 by 2, root 3 by 2 is greatest. Root 3 by 2 is greater than this. So option C. Third one, third configuration only, maximum. Let's move to question number 3. A charged particle of charge Q is moving in a circle of radius capital R with uniform speed small v. The associated magnetic moment mu is given by dash. Magnetic moment M equal to NIA. Previous formula, same formula. Here number of turns is not given, so M equal to I into A. And we know the formula for current. Current I equal to rate of flow of charge, I equal to Q by T. And this T is time period. And time period T equal to, we know formula, T equal to 2 pi by omega. And there is a relation between omega, that is angular velocity, and linear velocity, that is omega equal to R by V. 2 pi by omega is R by V. Then that we substituted, that only we are getting I equal to QV by 2 pi R. Okay. Then substitute this here. M equal to I is Q V divided by 2 pi R into A. Area pi R square. Pi R square. And this R square getting cancelled. Pi getting cancelled. Then M equal to QV R by 2. QV R by 2. QV R by 2, that is option A. Option A is the correct answer. Let's move to question number 4. The relation among the 3 elements, that's magnetic field, namely horizontal component H, vertical component V, and dip delta R dash. Here BE is the total magnetic field. That is, BE is resolved into 2 components. As this is the BE only, no? Yes, BE is the total magnetic field, and it makes theta angle, the theta angle only delta. Dip. Then this will be BH or just H, and this will be BV or just V. Okay, it's nothing but BH or H is nothing but horizontal component, and BV or V is vertical component. So from this, BE equal to, there is a sin del equal to V by BE. From that, V equal to BE sin del equal to BV or V equal to BE sin del. Just like BE sin cos theta, BE sin theta, BE cos theta. Similarly, H equal to, here H equal to BE cos del. What is del? Del is a dip, angle of dip. Then which option? Option B. Option B is the correct answer. Let's move to question number 5. Two bore magnets having same geometry with magnetic moments capital M and 2M are firstly placed in such a way that the similar poles are on the same side. Then its period of oscillation is T1. Now the polarity of one of the magnets is reversed, then the time period of oscillation is T2. Then you want to compare T1 and T2. Formula T equal to 2 pi into root of I by MB. Here I is the moment of inertia, M is the magnetic moment, and B is the magnetic induction or magnetic field. Here I and B maintain constant, therefore T is proportional to square root of, that is a 1 by square root of M. Okay. And T1 is proportional to square root of M1, 1 by root of M1. And T2 is proportional to or inversely proportional to square root of M2. Okay. And what is the condition? First, placed in such a way that the similar poles are on the same side. It means M1 equal to, adding these two, M plus 2M. M plus 2M. What is the value of M plus 2M? That is 3M. This is M1. Similarly, M2. M2 equal to opposite poles. So difference, 2M minus M. 2M minus M. How much? Just M. Then you want to compare. So T2 by T1. T2 by T1 equal to square root of inversely proportional. So M1 by M2. M1 by M2 equal to square root of M1 is 3M. 3M by M. M getting cancelled. M getting cancelled. Therefore, equal to root 3. It means T2 is greater than T1. That is, T2 is greater than T1. So which option? Yes, option A. That is, T1 is less than T2. Okay. Option A is the correct answer. Let's move to question number 6. An iron rod of susceptibility 599 is subjected to a magnetizing field 1200 ampere per meter. The permeability of the material of the rod is dash. Given, mu naught is given. And you want to find permeability of the material. What is the formula? Permeability of the material, mu m equal to mu r into mu naught. Okay, mu r into mu naught. Mu r into mu naught. And mu r equal to 1 plus chi. Mu r equal to 1 plus chi. What is chi? Chi is a susceptibility. That only this formula. Mu m equal to mu naught into 1 plus chi. Substitute this. Mu naught. What is the value of mu naught? Given already. 4 pi into 10 power minus 7 into chi. 1 plus chi. 1 plus 4, 599. 1 plus 599. 1 plus 599. How much? Equal to 4 pi into 10 power minus 7 into 600. Then simplify this. 6 4, 24. 24 into 10 power 2 comes there, becomes 10 power 2 into 10 power 2 into pi into 10 power minus 7. And answer is given in terms of 2.4. So 2.4 means into 10 power 3 into 10 power minus 7. That is 10 power minus 4. So 2.4 pi into 10 power minus 4. As per the unit, T m a power minus 1. Which option? Option D. Option D is the correct answer. Let's move to last question. Nickel shows ferromagnetic property at room temperature. The temperature is increased beyond Curie temperature, then it will show. It will show what? Nickel is a ferromagnetic material is given. And temperature is increased beyond the Curie temperature. The temperature is greater than Curie temperature Tc. Then what will happen? It's converted into paramagnetic material. Paramagnetic material. So which option? Option A. Option A is the correct answer. Okay. Thank you, students. In next session, we will go to the problem solving session in next chapter. Thank you.